Hello, everyone. Thanks for joining and welcome to another session of our Day One Beyond series, where we take you through various topics and activities related to building on an Oracle Cloud. Our today's session is Getting Started with Oracle Cloud, which will cover key cloud fundamentals, terminology, and best practices to get the most out of OCI. I'd like to introduce Hannah Raksha and Dion Locklear as today's presenters. That said, I'll hand it over to Hannah.
Thank you, Borna, and thank you everybody for joining us today. We're going to go ahead and dive straight in. So what we'll be covering today in our Getting Started with OCI webinar, we're going to start with the foundations of OCI. Following that will be the overview of OCI services, such as identity and access management, networking, compute, storage, and database. And then once I've done those presentation pieces, I'm going to hand it over to Dion for the demonstration where he's going to walk through some of the services. Now, foundations of OCI. So between on-prem, you can see here we have our customer responsibility. On-premises is entirely customer responsibility. And then as we go through our as-a-service models, this is where the cloud service provider, or in this case, Oracle, start to take on more responsibility. So for infrastructure as a service, that is the physical infrastructure network and virtualization. Platform as a service, we add that guest OS. And then for software as a service, the only thing the customer is responsible for is user access/identity as well as the data. Between on-premises and infrastructure, we have a full cloud hosting that is offered as a middle ground between the two. It's called Cloud at Customer, and it allows you to access cloud features that are unavailable on premises, but in the comfort of your own data center. Here we have our high-level overview of our Oracle Cloud ecosystem. So starting here at the base, we have our different infrastructure deployment options, followed by our cloud services, and then at the top, we have our application layer. So again, going back to the bottom, we offer several different types of deployments so you can take advantage of any sort of regulatory or latency compliance needs. We have several different options, including public multi-tenant in our commercial public regions, government multi-tenant in our US and UK government regions, as well as single tenant on premises for our cloud at customer offerings. That again is our hybrid cloud offering. On top of that are our cloud components. So today we're going to be going over a few of the foundational pieces, namely compute, storage, networking, etc. And then finally at the top is the application layer. So whether it's Oracle applications, custom applications, or even ISV applications, it fits into your Oracle Cloud ecosystem. So in beginning your cloud journey, the first step is always selecting the region you want to host your tenancy in. This map shows a variety of different regions that are already live as well as planned around the world. So if you look at the legend in the bottom, you can see not only our footprint, but our multi-cloud options. We offer interconnect as well as a few AWS options. Now let's go ahead and take a look closer at OCI regions. So again, OCI is hosted in regions across the world to provide geographical separation. A region can be within a country, different countries, or even different continents. From there, each region is one or more data centers that we call availability domains. ADs rely on their own independent power, hardware, and networking, so that way they remain isolated from each other. This ensures that a failure at one availability domain most likely won't impact the availability of the others that are in the same region. Now, within an availability domain, there are typically three fault domains. Fault domains are just a grouping of infrastructure and hardware, and the purpose of fault domains is to protect against any sort of unexpected hardware failures or things such as planned outages for hardware maintenance. So following on top of our regions, we have our second building block, which is the physical network. So the physical network we have is non-oversubscribed, so you don't have to deal with any sort of noisy neighbors. What this means is OCI has reserved the exact capacity that you have signed up for, and no one else will be sharing or using your capacity. It also operates at a very high scale, approximately 1 million network ports in each availability domain. Building on another tier, we're going to discuss the virtual network. So the virtual network has this feature known as off-box network virtualization, which allows us to put all of the virtualization out to the network, which results in an vir isolated network virtualization. Because it's off box, this gives us nearly zero performance overhead and enables the next layer, which we'll talk about on the next slide, to take any physical form factor that gets plugged into our network. The main goal with this is to increase network performance, and it also adds a higher level of security by isolating any of these. So anything that would affect a single virtual network doesn't touch any of the other virtual networks, which is how we provide isolation in case of any sort of unforeseen attacks. Now, our final layer here at the top shows us different technologies that are included in your environment. So again, due to off-box virtualization, we can use these services side by side. The virtual network allows us to plug these services into our environment without making any sort of changes. So with that, that concludes the foundational overview or building blocks of OCI. But now we're going to move on to the overview of OCI services. But before we discuss our first service, I want to explain how security is built into your OCI environment. When we think about security, we think about primarily security tools, right? But in OCI, I want to emphasize that it's not only security tools, but it is built into a ton of different services to ensure that you get that secure environment. So for example, we have a number of layers here. We have identity, data, compute, networking, monitoring and prevention, and then internet and edge. In all of these, we have tools that are listed here at the bottom that can help build security in your environment. We're going to go ahead and start by discussing identity. Okay, so moving into Oracle Identity and Access Management portfolio. So this slide gives us a very quick visual of our full IAM portfolio. You can see these segments Oracle is focused on as these pillars. So strong and adaptive authentication, access management, identity store, lifecycle management, and access governance. And then on top of those two pillars, we have two parallel deployment tracks. The first is Cloud Identity Platform. So this includes OCI IAM, which is a full-featured ID as a service solution for workforce, consumer, and developer scenarios. Additionally, we have Access Governance, which is a cloud-native service. And then the second parallel track is the traditional Oracle IAM suite. We won't be covering all of these services today. We're just going to focus on identity and access management, but this is the base for your OCI platform. So previous section, we talked about tenancies, regions, and availability domains. Now we're going to go and discuss compartments. So a compartment is a logical grouping of related resources that can be accessed only by groups that have been given permission. So once your tenancy and admin users have been established, the first thing you're going to set up is compartments. They're a key part in establishing identity in your environment, and they follow a parent/child relationship where the root tenancy is sort of the beginning of that family bloodline. You can create different compartments to organize your resources, whether you do it by environment or by team, and then you will go ahead and apply policies to the groups for the compartments, and that depends on which users or resources you need to access those. So looking at the example here, we have our infrastructure admin, our shared services admin, and our IAM admin. You see here that in our infrastructure compartment, which is inside of Vision Corp and then inside of information services, the only people that have access to that are the infrastructure admins who have been given it through a policy. Similarly, we have shared services, another policy, and then if we see here for IAM admin, they need to access IAM, which is in the entirety of the root, so they'll have access to everything because they'll need access to the root, which then feeds down into the other compartments. Now let's talk about how to get access. So in OCI, this is done through policies. Policy is a document that specifies who can access which resources and to what degree. Policy needs a group and a specific identity domain, a verb, and then the resources you want the group to verb. I imagine that's clear as mud, so we'll jump further into that on the next slide. Important things to remember about policies is policies only allow access. They cannot deny it. This is due to the idea of least privilege, so we can't take away something they've never had. Policies also can apply to your whole tenancy instead of just a compartment. The syntax would replace compartment name with tenancy. So just looking very quickly at this example, we have policy A and policy B. A, allow group identity domain group A to manage compute in compartment A, and then allow group identity domain A group B to inspect compute in compartment B. So if a user is added to group A, that means that they are able to manage compute inside of compartment A, and a user assigned to group B can inspect compute in compartment B. If a user from group B tried to inspect or manage from compartment A, they would not be able to because, again, we follow least privilege, which means they do not have access until they are granted it. And then vice versa with A. So looking further into that policy syntax, so we have allow group default. Default is the identity domain that is in this example statement. Each tenancy includes a default identity domain that is created, and that contains the initial tenancy administrator's user and group. The default identity domain lives within the lifecycle of the tenancy and it cannot be deleted. If you don't identify, if you don't supply an identity domain, IAM will automatically use the default identity domain. So allow group default DB backup proj A to manage. So that's our verb. The verb options are inspect, read, use, and manage. And as we go down this, it is more responsibility, more access given. So to manage object family, so these are the different resource types. So there's all resources, database family, instance family, as well as if you wanted to do buckets or objects, VCN subnets, etc. In project A, this is the compartment, and then where conditions. Conditions there in brown is optional. It's if you wanted to make your policies more granular. So if you wanted to say, let's say, manage object family in project A where availability domain is US Phoenix 1. So that would be all of the resources that are specific to US Phoenix 1. Jumping into networking. So networking is architected from the ground up for maximum isolation as well as protection. We have several different networking products that I want you to be aware of at this point as an introduction. Those are VCN, subnet, gateways, and firewalls. So starting here on the left, this is the VCN. This is likely one of the first things that you set up in your tenancy as you begin to create instances. VCNs are your software-defined networks where you will be deploying your instances within a set IP range. Following that are subnets. So each VCN is subdivided into subnets. You can have more than one subnet in an AD for a given VCN, and these can be either public or private. If they're private, the instance contains private IP addresses that are assigned to VNICs. If it's public, it can contain both private and public IP addresses assigned to VNICs, which enables a compute instance to connect and determine how it wants to connect with endpoints inside as well as outside the VCN. Gateways, we have a variety of choices, and we're going to start by talking about the Internet Gateway. So the Internet Gateway provides a path for network traffic between your VCN as well as the Internet. You can only have one Internet Gateway for a VCN, and then after you create it, you must add a route for the gateway in the route table to enable traffic flow. The next gateway is our NAT gateway. So this gives an entire private network access to the internet without assigning each host a public IP address. Common use cases for this are updates or patches. This way the host can initiate an outbound connection as well as receive responses, but cannot receive inbound connections initiated from the internet. Our third gateway is our DRG, or Dynamic Routing Gateway. This provides a path for private traffic between your VCN and destinations other than the internet. So you can use it to establish a connection with your on-premises network via either IPsec VPN or Fast Connect. You can also use a DRG to establish a peering relationship between two VCNs. So if you have two VCNs in two different regions, you can use a DRG to enable a remote peering connection. VCNs and DRGs have a one-to-one relationship. So as a note, one VCN to one dynamic routing gateway. And then our final gateway is Service Gateway. This lets resources in VCNs access public OCI services, such as object storage, without using the internet or a NAT gateway. Now, final network service are firewalls. We have two. First is security list. So a security list lets you define a set of security rules that apply to all of the VNICs in an entire subnet. To use a given security list with a particular subnet, you have to associate the security list with the subnet, either during creation or afterwards. And a subnet can be associated with a maximum of 5 security lists, and any VNICs that are created in that subnet are subject to the security list that is associated with the subnet. Our second firewall is our network security groups, or NSGs. These let you define a set of security rules that apply to a group of VNICs of your choice. So for example, the VNIC that belongs to a set of compute instances all have the same security posture. You can use the given NSG you add to VNICs for the interest of the group, and then any VNICs that are added to that group are subject to the group security rules. Similar to security lists, you can have a maximum of 5 NSGs. Jumping into compute. So we offer a wide range of compute services for any sort of enterprise use case. So an instance is just a term that we use. It basically is a compute host. And then left to right, we have a trade-off between user management and functionality. So on the left here, bare metal, You get the full bare metal service with no noisy neighbors, and you're going to have some performance overhead. It is mainly for performance intensive workloads. You can use this if you don't need a hypervisor or if you need a specific hypervisor that you would like to bring to OCI. When to use it, applications that require high core counts, large amounts of memory, as well as bandwidth. Virtual machines. So this uses the hypervisor to virtualize the underlying bare metal server into smaller virtual machines. You can run VM instances on any sort of dedicated servers as well as single tenant that is not shared with other customers. And this differs from bare metal because of the hypervisor. You have the flexibility in shape and image, where the image that you use to launch an instance determines its operating system as well as any other provided software. So when to use this, applications that do not require the performance and resources of an entire physical machine. So containers. Containers allow applications to be more rapidly deployed, patched, and scaled. They support agile and DevOps efforts to accelerate development, test, and production cycles. Containers leverage the highly available Oracle managed private container registry service. And this is where they store and share their container images. So when to use this, any sort of applications with microservice-based architectures. Now, last on the right there, we have functions. This lets developers run serverless applications that integrate with OCI, Oracle Cloud applications, and third-party services. So with these, you don't have to worry about the underlying hardware. You can just get up and go with your code. When to use, if you just want to focus on the code and not worry about the underlying infrastructure. Moving on to storage. Oracle provides optimized storage for nearly any use case. We have local NVMe. So this local NVMe SSD provides the fastest performance for any transactional database and HPC use cases. So when you want to use it, any sort of big data, OLTP, or high performance workloads. Second, we have block storage, which is our most flexible application, which is our most flexible storage for application as well as deployment of any sort of tiered applications. So when to use it, apps that require SAN-like features, so Oracle DB, VMware Exchange. File storage offers a managed file storage service that scales up to exabytes, which makes it ideal for enterprise applications, big data, analytics, scaling out your applications, or any sort of container-based applications. And then at the end here, we have our object storage. This is Oracle's storage platform that can store an unlimited amount of unstructured data. The normal term for object storage is referred to as hot storage, where archive storage is cold storage. So archive storage is our long-term data storage. It is much cheaper than object storage, but the data has to be restored before you're able to retrieve and use it. Now for our final section for the demo, we have our database options. So from left to right, we have our automation as well as our management. So on the left here is more customer managed, less automation. And then on our right, full automation and is fully managed by your cloud service provider. So Oracle DB on compute, these are our VM and bare metal instances, single instance DB, and for any sort of backup retention or disaster recovery has DataGuard. Moving into our co-managed, we have two options, Oracle-based database service and Exadata database service with this one being more managed and this one being more customer managed. So these are your VMs with block storage, your standard and enterprise editions. This includes real application clusters, as well as data guard, automatic TDE, as well as automated backups and patching. Our Oracle Exadata database service is our extreme performance elastic scale-out enterprise edition. It includes all the DB options and comes in or can come in the dedicated infrastructure or cloud at customer. And then finally, our fully managed, we have Oracle Autonomous Database. So any workload, any scale, any criticality, it is the auto-tuning, patching, and scaling database. The infrastructure can be serverless or dedicated, and we have different flavors for it. Data warehousing, transaction processing, JSON, and then typically our Apex, which is our Application Express, our low code, is also run on Autonomous.
And we should be on my homepage for OCI. So what we're going to do in this demonstration today is go over a few of the core concepts that we covered in the presentation, starting with identity and access management. From there, we'll move on to virtual cloud networks, and we'll go over the process of creating that. From there, we'll move on to how you can generate your SSH keys, create a compute service, create and attach a block volume, and then for the end of this demonstration, we'll go over object storage as well as cost management. So with that being said, first thing that we're going to do is navigate to our upper left-hand corner, our navigation menu, and we're going to come down to identity and security. And from there, we're going to go ahead and go to our overview under identity. So here we have our overview page. As always on any page that you are on OCI, our overview page is going to give us a pretty good rundown of what we can expect from this service. So here we have a quick introduction to OCI identity domains, as well as an area where we can quickly get started with identity. So as we can see, we have our understanding identity domains here and the ability to learn more, setting up multi-factor authentication, syncing users from Active Directory, and configuring SAML and social identity providers. On the right-hand side, we have some FAQs. So what are identity domains? What type of identity domain should I use? And we also have some quick links here. And no matter where you are on OCI, you also have access to our dynamic documentation. So if we access the upper right-hand corner with this help button here, we have documentation that pertains to the screen that we're currently on. So this one being identity, quick documentation for IAM with identity domains, as well as an overview of IAM. So that's going to be our overview. What we're going to do here now is actually go over compartments. All right, so keep in mind that a compartment is a collection of cloud assets, like compute instances or load balancers or even databases. And by default, a root compartment was created for you when you created your tenancy. So it is possible to create everything in the root compartment, but Oracle does recommend that you create subcompartments to help manage your resources more efficiently. So as you can see on screen, we have several compartments in my tenancy currently, OCI BTNAS. This is going to be our root compartment, and these are going to be all of the children, our child compartments that comprise this root. So we have managed compartment for PaaS, Sandbox, Vision Corp, compartments to review, team projects, as well as customer projects. And if we wanted to quickly create a compartment, we can do so by accessing the Create Compartment button. We'll give the compartment a name. So my compartment. You can give it a description. And from there, you're good to go ahead and create the compartment. So I won't be creating it now, as we already have a plethora of compartments in our root. However, this is just to showcase how easy it is to go ahead and actually create that compartment. Simply give it a name, a description, and from there you have your logical separation of resources in which you can add to. And just to show you what a compartment looks like, if we go to our sandbox, we can see all of the child compartments associated with it. And we can also come down to my own compartment. So dlockly. And this is going to be the compartment in which I am able to spin up resources to my liking within our own tenancy. And of course, within your own organization, you can split up your compartment structure the way that you see fit. So that's compartments. Next, we're going to go ahead and view virtual cloud networks. So to do that, we're going to go down to networking and then virtual cloud networks. So again, I won't be creating a VCN here, but do keep in mind that VCNs are going to be private virtual networks that you set up in OCI, and you do have the ability to attach gateways, route tables, and security lists to specify routing and security rules. And if we access our overview, we actually have a few wizards that can help us create VCNs pretty quickly and easily. The first of which is going to be a VCN that already has internet connectivity. So this creates a VCN with a public subnet that can be reached from the internet, and it also creates a private subnet that can connect to the internet through a NAT gateway, and also privately connect to the Oracle Services Network. And here we can also view our details for what's all going to be included here. So again, it includes a VCN, our public and private subnet, our internet gateway, our NAT gateway, as well as our service gateway. And a nice fun diagram here as well. So to get started, we can just click the Start VCN wizard. Again, it's showing us what all we can expect in this creation process. All we need to do is provide the VCN with a name. So my VCN. The compartment in which we want to create this VCN. Again, we didn't create a compartment here in this demonstration, but I do already have one. So you'll get to choose which compartment you'd like your VCN to reside within. You can leave this default as you'd like, or if you'd like. And then the same with your public and private subnets. It just needs to be in the correct range, but the default range should be acceptable. You have the ability to go ahead and give it tags, and from there we can click next. And with two buttons, a name and a description, we're able to quickly go ahead and create our VCN. And again, I won't be creating it here as we already have a VCN in which we can view, but just to show how quick and simple that process is. And again, we have our gateways and subnets that are pre-configured within the wizard. So just to see what a VCN looks like, we have lab VCN here. We have the date that it was created, all the details here. You go to IP administration here and look at our CIDR block prefixes as well as our DHCP options. If we need to view our subnets, edit our subnets, we have the ability to do so, as well as create a new subnet if needed. And the same is going to be true of our gateways. So if I needed a dynamic routing gateway attachment, I can go ahead and create that here. This VCN is set up with an internet gateway. Same for our NAT gateway. We can go ahead and create that, as well as our service gateway. Routing, we have the ability to go ahead and view, as well as create our routing tables. So we have a routing table here. I can go to route rules, and I have the ability to add route rules if need be, or edit and remove route rules if need be as well. Security, we can create our security list, as well as create network security groups, and so on. So again, with the simplicity of our wizard, we were able to configure and create a VCN with internet connectivity in minutes. That's everything that I wanted to show you here for virtual cloud networks. Next, I'll go ahead and show you how quickly you can create SSH keys, and there are several ways to do so. The way in which I'll show you is going to be through our Oracle Cloud Shell. So to access the Cloud Shell, all we need to do is go to the top right, Developer Tools, and then click Cloud Shell. We'll give it a second to load. But when working with SSH keys, what we want to do is create a directory called .ssh. I do already have that directory. So we'll go ahead and move into it. And as you can see, I'm in my .ssh directory. I have something called a Cloud Shell key. This is just what I named my private SSH key. The Cloud Shell key.pub is here as well, so the public key. And then you don't need to worry about these. So to create an SSH key, it is as simple as using the following command. We'll do SSH keygen minus B 2048 minus T RSA minus F, and then we'll give that SSH key a name. I can leave that empty. And now it has generated an SSH key for me. So to view that, we can list. We have our SSH key as well as our SSH key.pub. So when working with SSH keys within OCI, it is important that you save this SSH key to your local machine somewhere, maybe in your notes. But if not, you do have the ability again to come in here and access it via the Cloud Shell if that's where you choose to set it up. And you're not limited to just the Cloud Shell for generating your SSH keys. We do have options as well for Mac OS, Windows 10 and 11, any prior Windows versions, including like Git for Windows or PuTTY, and then even SSH keys for Linux. But this is one way in which you could quickly generate SSH keys within the Oracle Cloud Console itself. And those SSH keys will be important for a number of the services that we'll be talking about today as well, including our compute service in which we'll be going to next. So to access our compute service, again, we're going to go back to our navigation menu. We'll go to compute and then overview. So OCI does offer both bare metal and virtual machine instances. Keep in mind that a bare metal compute instance gives you dedicated physical server access for highest performance and strong isolation, whereas a virtual machine is an independent computing environment that runs on top of physical bare metal hardware. And the virtualization makes it possible to run multiple VMs that are isolated from each other. VMs are going to be ideal for running applications that do not require the performance and resources of an entire physical machine. So you do have some options within the OCI compute service. So what we'll do now is actually navigate to instances. And here we can see some of my compute instances under the compartment dlockly. To quickly create an instance, of course, we'll click on create instance. You can give it a name or leave it as is. You'll need to make sure that you place it in the availability domain of your choice. We can leave it as AD1 for now. We also have some advanced options here, going over capacity type. So we have on-demand capacity, so you can place the instance on a shared host using on-demand capacity. Preemptible capacity, where you place the instance on a shared host using preemptible capacity, and this instance can be reclaimed at any time. Like capacity reservation, where you place the instance on a shared host and you have it count and gets a capacity reservation. Dedicated host, as well as our compute cluster. So these are just some of the advanced options. What is really important here is the determination of our image and shape, because again, these are going to go into whether or not we need bare metal versus virtual machine. So our image is just going to be the operating system that runs on top of our shape, the shape being the template that determines the number of CPUs and the amount of memory, as well as other resources allocated to an instance. So as you can see, we have a number of options for images here, whether they be under the hat of Oracle Linux, Ubuntu, Red Hat, CentOS, Windows, Alma Linux, Rocky Linux, and so on. All of our images are going to be comprised under this section here. So we can go ahead and leave this as is. Next, I'll show you what the shape looks like. So when selecting a shape, again, you need to determine whether or not you want to use the virtual machine or the bare metal machine. And from there, you can select your shape series and then your specific shape name. Once that is complete, we can go ahead and configure security, networking, including DVCN, in which we want this instance to reside in, our boot volume, as well as any block volumes that we want to attach as well. A boot volume is just going to be a detachable device that contains the image used to boot up the compute instance. And block volumes can be thought of as just additional storage that you would attach to this instance. From there, once you have reviewed your configurations, you have the ability to go ahead and create this instance. And again, I won't be creating it now, but we can go ahead and view one of my instances here in my compartment. We'll take a look at my instance. So under my instance, we have our details here. If we need to access this instance, we can go ahead and do so via the public IP address. You'll take advantage of this public IP address as well as the SSH key used to create the instance, as well as the VCN. In our networking section, we can view uh, our networking configurations as well as the VNIC and VCN associated with our instance. We can do the same for our storage, so our boot and block volumes. Security, we can add security attributes if need be. We have management, OS management, and so on. So within minutes, we're able to create a compute instance as well as our virtual cloud network in which that compute instance resides. And with that, we have access to our instance as well. So just a few more things that I'm going to go over in this demonstration before handing it back over to Hannah. And the first of which is going to be the block volume. So we're going to go over to storage now, navigation menu, storage, and we'll go to block storage. So a common usage of block volumes is adding storage capacity to an OCI instance. Once you've launched an instance and you set up your cloud network, you can create a block storage volume through the console or API. And once created, the volume can be attached to an instance using a volume attachment. Once that volume is attached, you can connect the volume from your instance's guest operating system using ISCSI or paravirtualized mode. And the volume can then be mounted and used by your instance. So now that we are here on the block volume store or page, of course, all we need to do is go ahead and click on create a block volume. We'll give it a name. So my block volume. We'll select our compartment as well as our availability domain. We have options here for volume size as well as performance. So we can leave it on default, which will give us a volume size of 1024 gigabytes, a volume performance of balanced. And we can see our IOPS and throughput here, or we can go ahead and customize this if need be. However, I'll leave it on default for now. We have our reservations. So this is going to enable persistent reservations for the ISCSI volume attachments. We can enable that if need be. We have our backup policies, whether or not they're going to be gold, silver, or bronze. And just a quick recap on block volume backup policies. There are 3 predefined backup policies, again, in our bronze, silver, and gold. And each backup policy does have a set of backup frequency and retention period instructions. So starting with bronze policy, the bronze policy does include monthly incremental backups. It runs on the first day of the month, and these backups are going to be retained for 12 months. And this policy also includes a full backup run yearly on January 1st, and full backups are going to be retained for 5 years. Moving on to the silver policy, this includes weekly incremental backups that run on Sunday. So difference here, bronze policy includes monthly incremental backups, whereas silver policy includes weekly incremental backups. Again, these backups are going to be retained for 4 weeks. Policy also includes monthly incremental backups that run on the first day of the month and are retained for 12 months. It includes a full backup that's run yearly on January 1st, which is going to be again retained for 5 years. And then last, we have our gold policy, which includes daily incremental backups. So biggest difference between the policies, bronze, monthly incremental, silver, weekly, and then gold daily. These backups are going to be retained for 7 days. And this policy also includes weekly incremental backups that run on Sunday that are retained for 4 weeks as the other two. And again, a full yearly backup on January 1st, retained for 5 years. So that was a lot. I apologize, but it is important that we go over those backup policies and the differences between them. So we can just leave this as gold for now. I won't actually be creating it. And from there, we have our cross-AD region replication. So this will enable asynchronous cross-region volume replication. You can go ahead and check that if you'd like to. And we have volume encryption. So we can encrypt using Oracle managed keys, or we can encrypt using customer managed keys. This just requires you to have access to a valid key management key. And once done, we can go ahead and create the block volume. And I won't be going into any of these, but again, a block volume is just going to be additional storage for any of your instances there. So that's all I really wanted to talk about when it comes to block volumes. The last two things that we'll do briefly, we'll be going over object storage as well as cost management. So staying in the pane of storage, we're just now going to navigate to object storage. Object storage does provide unlimited high performance, durable and secure data storage, and data is going to be uploaded as objects that are stored in buckets. And these buckets are going to be super easy to create. We'll click on create bucket. We can leave this name as default, or we can give it another name if you'd like to. We'll have our default storage tier. So remember, we have hot and cold storage. We can put this in archive storage and it would be cheaper. However, it would take longer for us to retrieve that. We have the ability to enable auto tiering if we need to, or enable object versioning and so on. And from there, we can really just go ahead and create this bucket. Just to show you what a bucket would look like, we have our details here. So in general, we have our usage. It's telling us how many objects I approximately have within this bucket. It is one. It's telling me the size. Uncommitted multi-part uploads, approximate count. Uncommitted multi-part uploads, approximate size, so on, are features of this bucket. This is going to be our standard storage tier. This is a private bucket using Oracle managed key for encryption. Auto tiering is disabled. We're emitting object events, and object versioning is also disabled. If we come over to our objects, we can see what actually lives within the bucket. So I have an Excel sheet called Sales Optimization Data Final. What I really want to show you here is how we can actually create a pre-authenticated request for this object. So to do so, all I would need to do is navigate to the three dots here. We'll go ahead and create pre-authenticated request. When creating a pre-authenticated request, we need to specify the target. So the target can be the bucket at large. This would apply to all objects in the bucket. Or I could specify the object itself, or all objects within the bucket that contain a certain prefix. I'll just leave it on the object itself. So again, sales optimization data final. It's that Excel sheet that I had. The only object that exists within this bucket. I do have the ability to go ahead and specify my access type for this object. So this access type will permit object reads. This will permit object writes. And this will permit object read and writes. And from there, I can go ahead and specify my expiration. So we can let this expire on January 13th at 1900 hours UTC. When creating that pre-authenticated request, it'll give me this link. And now anyone has access to Sales Optimization Data Final as long as they have access to this link. That's the cool thing about pre-authenticated request and object storage buckets. And the last thing that I wanted to show is going to be briefly cost management. So what we'll do is we'll go down to billing and cost management, and we'll go to our cost management overview. So OCI provides various billing and cost management tools that make it easy to manage your service cost. You can estimate costs, create budgets to set spending thresholds, view usage, and visualize your spending charts and reports. So you also have the ability to view your subscription details, invoices, payment history, as well as manage your payment method and your rewards, your local support rewards. So going over a few terms, we have first cost analysis. So cost analysis provides easy to use visualization tools to help you track and optimize your OCI spending. Here we can see we have the ability to drill down reports by different metrics. So cost by service and description, by service and SKU, service and tag, compute cost by compartment, and monthly cost, and so on. A number of ways in which we can drill down in these reports. We can specify a start as well as an end time, as well as levels of granularity. And if we scroll to the bottom, we'll see the associated chart. So here we have cost by service and cost by date. Under details, we can see uh, the cost by service really split out between the different services. And it is going to be color coded and associated with the following chart that we see up top. So this is going to be cost analysis. If we come down to go down budgets. So you can use budgets to set thresholds for your OCI spending, and you can set alerts on your budget to let you know when you might exceed your budget. And you can also view all of your budgets and spending from one single place in the OCI console. So you can do that by creating a budget, give the budget a name and a description, a scope. So here we have the ability to either look at a specific compartment or a child tenancy. We can specify the schedule, whether that's going to be a monthly or a custom schedule, the amount, the day of the month to begin the budget processing. And then from there, we can go ahead and set up that budget alert rule. So we can get notified when we either approach or exceed the specified threshold. And we can do that. We can go ahead and create an event in which recipients would be emailed. So that's how you create a budget. And I see we're getting very close to time. So the last thing that I'll go ahead and talk about here is going to be the cost estimator. So the cloud cost estimator helps you figure out your estimated monthly usage and costs for OCI and platform cloud services before you commit to an amount. And if we go back, let's see where the cost estimator is. I believe it is going to be a tool outside of the console. So happy to send you documentation on how to access the cost estimator as well. And again, in the interest of time, I think I'm going to go ahead and pass it over to Hannah to give closing remarks on our presentation. So thank you all.
Thank you, Dion. I appreciate it. If you wanted to learn more, we have a variety of different options, including our cloud resources, such as courses through Oracle University and cloud training. If you want hands-on experience, we offer our free tier as well as Live Labs and Code Innovate. If you want to dive into the details, we have our cloud adoption framework as well as documentation. And then this lab specifically is linked here. And of course, we have our YouTube channel, which provides a variety of these videos. So what about training for your organization? So right now we're here, day one and beyond. So this is our one-to-many virtual webinars and workshops. We also offer Quick Shot Live Labs, which is a balanced blend of theoretical knowledge with practical application, and then our personal training. So this is a one-to-one customized Oracle Cloud training with a variety of different session times and includes a presentation demo format. Of course, if you're looking to build out a specific use case, there is developer experience. This is a 5 half-day online event where Oracle engineers co-develop your most pressing use cases. which allows you to walk out with a first pass prototype of your anticipated solution. For any of these, email us at personal trainer or Code Innovate. And then the rest of the series for the month of January. So we're right here right now, Jan 6th, getting started with Oracle Cloud. We have another course series, as well as we're kicking off our new AI potential series, as well as continuing Oracle AI database. We have a hands-on, security, and then a did you know. With that, thank you all.
And we hope today's session was beneficial to everyone, and we hope to see you again.